In this video, we'll learn about the process of normalization in database management systems. Normalization is a process that is used to evaluate and correct table structures. That is, we are going to try and understand if there are any problems that occur with the structure that we already have within our database, and then we try to apply a certain set of rules so that we can get rid of redundancies and inconsistencies. Redundancy is when multiple copies of the same data occur at various places, and these typically lead to problems later on. Because of this, there are certain anomalies that arise in databases. For example, let us consider this following structure. This is an example that has been adapted from the prescribed textbook for database management systems by Peter Robb and Carlos Coronel. Now, this structure is trying to capture all the information about a set of projects and a set of employees that work on these projects. If we observe this structure closely, we notice that there are a set of 3 projects, each of them associated with a given name, and there is a set of employees that works on each project. Each employee belongs to a certain job class, and every job class has one fixed rate or charge per hour. Now, every employee works for a certain amount of hours on a given project, and the charge for their job class helps in determining the total charge or the total amount that they earn per project. So at first glance, this looks like a pretty decent structure in the sense that it gives you all the information about what are the projects, who are the employees involved with each project, and what is the total amount that they are making per project. Now, if we observe the structure more closely, we observe that there are certain problems that might come up because of storing our data in this particular method. First, there is a lot of data redundancy that occurs in this particular structure. That is, the same kind of data is being repeated multiple times. We notice that for one particular job class, there is a fixed charge per hour. And now, so if I have the term programmer being repeated multiple times, the charge for a programmer, which is 80, is also being repeated at a lot of different places. Each employee is working on multiple projects, and so the employee's number, his name, their job class, and their charge per hour is also being repeated at multiple places. So now let us discuss the various kinds of anomalies that might come up because of having redundancy in our data. The first kind of anomaly that we'll discuss is an update anomaly. Update anomaly typically means that when you're trying to update data at any one given location, because of the inherent redundancy, you will be forced to do it at multiple places, and this might lead to inconsistency later on. For example, if supposing we decide to change the charge per hour for a programmer from 80 to 100, we notice that even for this small simple example, we'll be forced to do that update at 5 different places. The second kind of anomaly that typically occurs in these kind of structures is an insertion anomaly. An insertion anomaly is when you try to insert new data into your given structure, and you're forced to create some other kind of dummy information just to be able to fit in the given structure. For example, we notice that the employee information is closely tied in with the project information. So, for example, if a new employee has joined our company and we haven't yet associated them with any project, there is no way for us to include that employee's information in this given structure. And for that reason, we will be forced to come up with a dummy project number. Another kind of anomaly that might occur in structures like this is a deletion anomaly. A deletion anomaly is typically when trying to delete one piece of information will usually unknowingly lead to the deletion of other associated information. Now, for example, let us take the case of employee number 9, who happens to be a trading expert working on project number 21. If employee 9 chooses to leave the company and we want to delete her particular data from this particular structure, we also lose some associated information. That is, a trading expert makes 200 charge per hour. Because employee 9 happens to be the only trading expert in our entire example, also the charge per hour for that particular job group is also lost when we try to delete this particular employee. So because of the inherent redundancy in this structure, we notice that it is also giving rise to a lot of different kinds of anomalies. Normalization is that process wherein we try to follow a set of rules and then try to break down our given structure into a more simpler and cleaner structure so that we get rid of all these redundancies and inconsistencies. There are various levels of normalization at which our database can be in. The first basic level is the first level of normalization, also referred to as the first normal form, which is pretty straightforward. What a first normal form means is that whatever data that we have within our table should strictly follow the rules for a relational model. Now, a relational model is what was actually proposed by E.F. Codd as a method for storing huge data banks. And in the relational model, they follow the basic mathematics underlying a table structure. In the relational model, you're not allowed to have multiple values within any one individual cell. That is, any intersection of a row and column, which we call as a cell, should only have one single value. That is the first rule. And the second rule of the relational format is that once all our data has been converted into relational format, there should be a clearly identifiable primary key. A primary key is any column that satisfies the properties of being both unique and not null at the same time, and therefore helps us in uniquely distinguishing one row from another. So now the given structure, if we try to convert it into the first level of normalization, we come up with the following table. What we have done here is, instead of having one single group per project, we have separated out all employees and created a separate row for each employee that works on a project. And so this looks like the data is already in relational format. The other condition that we have to meet is that there should be a proper primary key within this structure. Now we notice that only project number cannot serve as a good primary key since it is repeated multiple times for as many employees that exist within one project. Also, we notice that each employee is working on multiple projects. Therefore, just employee number also cannot serve as a primary key. So in cases like these, where one single column doesn't satisfy the requirement of a primary key, what we usually do is choose a combination of columns to serve as our primary key. This is also referred to as a composite primary key. So for this particular example, when we try to convert our data into the relational format, our primary key could be a combination of project number and employee number. We notice that the combination itself of project number and employee number is always unique. That is, it is never repeated. After having converted the table to first level of normalization, if we choose to convert it into the next level, which is the second level of normalization, the rule that we have to follow is that there should not be any partial dependencies within our database structure. A partial dependency means any kind of a dependency where some of the columns are dependent on a part of the primary key but not on the entire primary key. Now, for us to understand partial dependencies, we first have to come up with a list of all the functional dependencies that exist within our given structure. A functional dependency essentially means that if we know the value within one given column, if we will be able to determine the value of another column, then we say that the second column is functionally dependent on the first column. For example, we notice that for one given project number, there is one associated name. So knowing a project's number will help us in determining its name. In a similar way, knowing an employee's number will help us in determining that employee's name and the job class to which they belong and the charge per hour for that particular job class. One more dependence, functional dependence we notice in this example is that if you can just know the job class, you can also determine the charge per hour. For example, for a programmer, the charge per hour is 80. Now, in order to determine total charge, we will have to know both the combination of project number as well as employee number. And like we all know, a primary key helps us in determining all the other columns within the table. So the first functional dependency that we notice here is that our primary key, which is a combination of project number and employee number, helps us in determining the rest of the columns. Other than this functional dependence, we have three more dependencies. Project number helps us in determining the project name. The employee number helps us in determining the employee's details. Job class helps us in determining charge per hour. Having determined all the functional dependencies, our job now is to remove partial dependencies from the given structure so that our database moves from first level of normalization to the second level of normalization. Like we have said already, the partial dependencies within this given structure are project number helps in determining the project name, and employee number determines employee name, job class, and charge per hour. Our primary key, composite primary key, was project number and employee number. So any dependence which occurs only on one part of this primary key is a partial dependence and has to be removed from the given structure. And what we do is we remove these partial dependencies and create new tables for each of these dependencies. One more thing to note is that conversion to 2NF or the removal of partial dependencies occurs only in cases where we happen to have a composite primary key. For example, if my table already had only one single column that acted as a primary key, then the question of a partial dependence doesn't even arise. And so there is no question of removing partial dependencies, and hence our table which is in 1NF would have already been 2NF. So second level of normalization only comes in when our primary key happens to be a composite primary key. So now converting our structure from 1NF to 2NF changes the entire huge table. The single table that we had in 1NF is now broken down into three new tables. We create a new table called as project for our first partial dependence. Project number helps in determining project name. The second partial dependence helps us in creating a employee table wherein employee number acts as the primary key and rest of the employee details can be determined from employee number. A third table assignment is still dependent on the complete primary key, that is the combination of project number and employee number. This helps us in determining the number of hours that were billed for each employee on that particular project, and hence helps us in figuring out the total charge. So our structure, which had one single table in first level of normalization, now has three smaller tables at the second level of normalization. So this is the table structure at second level of normalization. Moving on to third level of normalization, a database structure or a table is said to be in third level of normalization when it does not contain any transitive dependencies. A transitive dependency is defined as one non-key column, that is any one column that is not a part of a primary key if it helps us in determining another non-prime or non-key attribute. Such a dependency is referred to as a transitive dependency. Now we notice that we had this dependency where if you know a person's job class, you would be able to determine their charge per hour. Also, neither job class nor charge per hour are a part of our primary key. Hence, this is a transitive dependency and needs to be removed from our existing structure if we want to move our entire database into the third level of normalization. So now, in a similar way that we did for second level of normalization, we try to remove this particular dependency and create a new relation or table for it. Our existing employee table will now be converted into two smaller tables. Employee number helping determines the employee name and job class. This is one particular new employee structure, and we create one more table called as job, wherein job class happens to be the primary key, and this helps in determining the charge per hour. So the resulting table structure in 3NF is we have a project table with only deals with project details, an employee table with employee number as the primary key and his name and job class. We have a job table which holds details about a job class and the charge for that particular job class. We finally have an assignment table in which the primary key is a combination of project number and employee number,